Next up in Chapter 5 is the concept of molar mass. We're going to be using this a lot. It's found on pages 83 through 85, and it's from exercise 5C. Let's deal first with the definition. What is molar mass? Well, it's the same as the mass of 1 mole, also called atomic mass, also called formula mass, also called atomic weight, also called formula weight. And basically what we're talking about in general is the mass in grams of 1 mole of the particular atoms of whichever element we're looking at. And these are found on the periodic table. So, when we're looking at the periodic table, and we're looking at, say, aluminum, you remember that, and that's the atomic number. This number has to do with the sum of all the different isotopes and their number of protons and neutrons in the nucleus, and then the relative percentage of the different isotopes that are present in the element that's ever found anywhere. And the key to this is that, remember, because this is a periodic table of the elements, not of the isotopes, this is the average of all of those isotopes, and it's the take-home number which says for every 1 mole of aluminum you have 26.98 grams. These units are in grams per 1 mole, okay? Grams per 1 mole. So if you have 1 mole of carbon atoms, that's going to weigh 12.01 grams, all right? That's why the units here, grams per 1 mole, are so important. Once we start and get that down, the working of the problems are very simple, especially if you use your factored label method. You've got one number. We've got one number. We've got one number. We've got one number. So that makes these problems easy because you just have to find a conversion factor that goes between that number and its units and the units of the answer that you want. Alright, so copy these down, hit pause, come back, and we'll work through the problems. Pause. Okay, so you're back. Let's roll. 3.21 moles. Mass to moles. What's the relationship? Right there. Mass to moles. So you look up for sodium on the periodic table. There it is, 22.99 grams per every 1 mole. The moles has to go on the bottom, and the 1 goes with the moles, and the 22.99 is the number of grams per 1 mole. Moles cancel. You're left with grams. This is 3 sig figs. This is 4. So the answer is going to be 3. Man, it just doesn't get any easier than that. So let's punch it into our calculator. 3.21 times 22.99. I do not want you to memorize adding or subtract, multiplying or dividing. I want you to use your units and cancel things out. I get 73.8 grams. Hopefully that's what you got too. Okay, let's keep it going. How many moles are in this many grams? Well, we've got one number. Let's start with that one. Okay. Including the units, if we have grams on the top, the relationship between moles and grams, or moles and mass, is found here. On the periodic table, we're looking at V, which is vanadium. Grams goes on the bottom, moles goes on the top. That's a direct relationship. One conversion factor. Okay, so we might like do it like this. Periodic table. So all you got to do is figure out for vanadium, what's the story? Well, the story for vanadium, which is element number 23, is that 1 mole of vanadium atoms weighs 50.94 grams. Okay, so the 50.94 goes with the grams, the 1 goes with the moles, grams cancels, left with moles, 3 sig figs here, 4 sig figs here, 3 sig figs in my answer. Now it's just plug and chug. Again, I did not memorize a single thing here. I didn't just multiply, I didn't just divide. I used my conversion factors to tell me what I needed to do. The answer I have is 2.89 times 10 to the 7th moles. Okay, next problem. What mass, remember mass is really generic. It's like saying what time. Well, you know, how long does it take to get from here to your dorm room? Well, it could take you the same amount of time, but you could say that time in minutes or seconds or hours or centuries or decades or weeks or however you wanted to measure it. So mass is a generic, so mass can't be the answer. It would be sort of like saying, how much money did you make last night at the bar on tips? And the answer would be, or you know, at the restaurant, the tips. And the answer, you wouldn't say 37 money, right? You'd say $37. But then again, dollars isn't really careful enough because you could have gotten Canadian dollars or some other kind of dollars. So the units that are most easy between moles and mass off the periodic table are going to be grams. So how do we take care of this business? 4.1 times 10 to the minus 8th moles. Since we want to get mass and grams is easiest, there's the moles, cancel out. The 1 goes with the moles, and what goes here? Well, this is H2O molecules. And the way we take care of this is we add them together. Molar masses are additive. So we have 2 hydrogens, or 2 times 1.008 grams per mole, and 1 oxygen, 1 times 16.00. Let me show you real fast where those came from. Here's hydrogen, 1.008 grams per mole, but there are 2 hydrogens. And there's oxygen, 16.00 grams per 1 mole. We have 1 mole. So you add those up, and you get 18.016. 18.016 grams per every 1 mole. 2 sig figs here. Quite frankly, this only has 4 sig figs, but we didn't round early. So the answer in grams, 4.1 times 10 to the minus 8th times 18.016 is 7.4 times 10 to the minus 7th grams. Alright, one last problem to deal with. No harder than any other. 121 grams of LIBR. And they want to know how many moles. The formula units is almost not even important. It's the LIBR that we're dealing with, and we're getting from grams to moles, and that's the periodic table where you find your conversion, the molar mass. Grams are on the bottom, moles are on the top, because that's how you get moles in your answer. The 1 always goes with the moles, so now we just have to figure out how many grams is in 1 mole of this ionic molecule? Well, you have to add it up. What do we got here? Let's see if you can see it. There's lithium, 6.941. And where's bromine? Bromine, there it is, 79.904. Alright, so lithium, there's one of them, 6.941. Bromine, 79.904. That's 5, 4, 8, 6, 8. That's the molar mass of this entire ionic molecule, this entire formula unit. So 86.845 grams. Cancel. We're left with moles. 3 sig figs in our answer because this has 5. So it's just punch it in and see what you get. 121 divided by 86.845. Alright, I get 1.39 moles. That's it. Nothing to it. Good luck. Pound out a whole bunch of examples from 5C.